Now, as an 8-year-old, I was utterly fascinated by the ideas of traveling through a galaxy. And I remember asking myself, could humans actually achieve this? Well, today, I am here to explain the question that utterly fascinated an 8-year-old me. Could humans actually achieve interstellar space travel? What is interstellar space travel in the first place? Well, quite simply, it's the movement of a spaceship from one star system to another. A star system is quite literally a group of stars bound together by gravity. And the closest star system to Earth is called Alpha Centauri. Behind me, highlighted in gold, is Alpha Centauri, related to Earth. Now, obviously, moving a spaceship from point A to point B is easier said than done. And the first problem humanity would consider is distance itself. Gaps between star systems are so incredibly huge that they're calculated in light years. A light year is the distance light can travel 1 year, and Alpha Centauri is 4.37 light years away from Earth. To put into perspective how great this distance is, if the Saturn V rocket were to travel at its maximum speed, it would take it 120,000 years to reach the star system. Now, another issue concerning space travel is space itself. The massive amounts of radiation can damage human DNA and also crews and the spaceship itself. Space debris can hit the spaceship and break its hull irreversibly, as tiny specks of dust colliding with the spaceship can also be damaging. And the final issue are humans itself. The extreme mental toll of being isolated in space for such a long time is extremely detrimental. Now, why would humans bother with interstellar space travel in the first place? Well, humans could take this as a challenge to show how smart we are and how far we've come. Also, humans might not have a choice in the future. The world might be so crowded and the earth might be so polluted that we simply need to colonize another planet to be able to survive. Now, I'd like you to imagine Earth 600 years in the future. Our technology has thrived, and now we're setting our eyes on another goal, far beyond our solar system, Alpha Centauri. In this scenario, I will break down how humans design a spaceship to travel such a large distance and survive along the way. The first problem we must consider is the material the spaceship will be made from. The material needs to be lightweight and durable, and the first option humanity could consider are carbon nanotubes. Carbon nanotubes, or CNTs, are sheets of carbon rolled up into a tube. Carbon nanotubes are extremely great at absorbing kinetic energy and can spread it out over a large area. However strong CNTs are, they can't withstand the force of a large meteor. This is where the Whipple shield comes in. The Whipple shield is a large hexagonal-shaped shield placed in front of the spaceship. Made from graphene-based alloys, graphene is single layers of carbon placed in a honeycomb shape. The Whipple shield can break down smaller pieces or larger pieces of rock and also absorb the energy from these meteorites. Next is the propulsion systems. There are three options humanity can consider. The first is the Bussard ramjet. This is basically a giant funnel traveling through space. The Bussard ramjet takes in hydrogen atoms and presses them into a nuclear fusion reactor. This fuses atoms together at such a high temperature that they release a massive amount of energy, which can be used to propel the spaceship. The next option humanity can consider are antimatter rockets. This is where protons and antiprotons are collided together. Antiprotons are negatively charged protons, and when they collide, they release a massive amount of energy at an almost 100% efficiency. The final option is Project Orion. First developed in the 1950s by American engineers, Project Orion works by detonating small nuclear explosions behind the spaceship, propelling it forward through space. Now, building the spaceship is only half the story. How would humans survive on board? Well, there are once again three options. The first are frozen embryos. These type of ships contain no humans for now. Instead, a highly advanced AI system takes care of the spaceship. and make sure everything is all right. Then, when the spaceship is near its destination, the AI system births these embryos and trains them into a highly intelligent group of colonizers for the new planet. The next option are generation ships. This is when many generations of colonists die and live upon the same spaceship. This type of spaceships may avoid the ethical concerns of frozen embryos. However, they rely on a complete closed-looped ecosystem to survive. Finally, we have suspended animations. This might be the most sci-fi solution. Suspended animation is when humans are placed inside of a cryogenic sleep. This massively reduces the amount of energy, water, and food needed upon the spaceship. However, the cryogenic sleep severely damages their muscles. Now, I'd like to turn your attention back to the year 2625. After decades of international cooperation and scientific research, humanity has built their first interstellar arc, natural selection, behind me. The large shield in front of it is the Whipple shield, absorbing impacts from meteorites, and the main body of the spaceship is built from CNTs. Humans on board are stored in frozen embryos, and the actual spaceship is powered by nuclear fusion. Although interstellar space travel might be impossible now, I believe that in 600 years, it could definitely happen. For example, 600 years ago from now, in the year 1400, if we showed a person from there, a smartphone from now, they would think it's impossible. And I believe the same logic can be applied to the year 2625. Thank you.